Okay, so we've got a few people around the table. We've got, my name is Evie, and your name is?
My name is Marit.
I'm Mari, I'm going to turn you up. Try that again.
My name is Marit.
Is that better? Yeah.
Mikey.
And we've got Rick in the corner as well, on visuals. And my name's Evie, and today we're on the second day of the Festival of Genomics. So what's been happening so far? What kind of trends?
I can tell you some of the big topics yesterday. I mean, we were obviously there's a lot of talk about data and who owns the data, and are these companies 23andMe got a lot of airtime, although a lot of criticism as well. There's a lot of talk as well about what the interface between the public understanding of genomics, if they've got any at all, and the very in-depth, with all this data and information and understanding gradually, slowly of all the how the genome translates into genes and into proteins is so complicated, and how can you possibly boil that down into anything that the public understand? That was a big question. And do they need to? And some people were saying that genetics should be taught in primary schools. So there's a few things, and there was a lot of talk about who's going to pay for all this. Should it be a government NHS thing, or should it be a private thing? So there's some of the topics.
Oh, okay. I like the idea. Should genetics be taught in primary school? Is this something that people really don't understand? Who should be funding the research today? Excuse me, madam, who's just walking past? Don't worry. What kind of trends did you notice?
Well, I think genetics and genomics should be taught indeed in primary care, and it's part of life. It's the new way of what's happening now. So a little different from me, how it was for me.
So do you feel like let down? You've obviously had a career in science. Do you feel like if you had been taught more in primary school, that it would have been a more successful career? Or we've got some.
In a way, I think it is part of that. The question that kids ask: where do we come from? There's a strong genetic component to that, but we don't really. We just talk about, when mummy loves daddy, and and they want to have a baby, and all this, but they don't explain the genetic side of it, and how different traits are inherited. I think it is that same birds and the bees discussion.
And I went yesterday to listen to a talk about, it was ethics in sort of around genomics ethics, and really sort of little things like, for example, the speaker said there is no race, so we're just about the same. And you see, genetics can also help the children to understand that many of our differences are actually really superficial, and genetically we are just about the same. So it would be to understand also people with rare diseases, and maybe it's less bullying when people have better understanding, and less sort of segregation, less sort of them and us sort of. I think there's too much of that in the modern society.
And do you think that's a trend that's growing at the moment? I know there's been a few books about it recently, about that there's a rise in people thinking there are huge genetic differences, and when actually we don't really have them. Do you think that's a trend that's growing, and how do you think it can be counteracted?
Well, I think, I'm kind of... A lot of people were talking about this talk yesterday, about the thing about race, and how race is a kind of cultural construct more than anything else, and but I think it's actually the place of geneticists and genomics to confront this question of race. I think we're actually quite reluctant to address it because of the kind of pseudoscience that came in the past about with eugenics and all this kind of stuff, and how scientists use their current understanding of genetics as a way to make themselves superior. But I think we actually need to tackle this question of race head on, rather than just kind of be scared of talking about it.
Okay, so maybe we're a bit scared about the information that genetics research can tell us. I don't know if other people maybe around the room are interested. We've got a few people in the coffee queue who might wonder what we're doing and think, I really have some opinions about the Fest of Genomics. I want to come down and grab a seat. You're very welcome to, guys, so just come and grab a seat.
I personally think it could be done with artificial intelligence. You could actually have part of, if you can do these things online, you could also potentially have the counselling online done mostly by computer.
Yeah.
Genetic counselling online.
Yes, as a family doctor, yeah, of course, we have 10 minutes per consultation, so there's not a huge amount of time for genetic counseling there, but one can chip in a bit. But I also think that some of the genetic counseling could be done in groups, patient groups, so that we are actually trialing group consultations for diabetes at our surgery. And yeah, but there is certainly in Bristol near great shortage of genetic counsellors and long waiting lists to be seen by geneticists. So yeah, more training is needed.
So genetic counselling, can it be done by a human? Can it be done in groups? Can it be done by AI? Would you want an AI program to give you some genetic counselling once you receive your results?
Well, I think you definitely wouldn't want to have an AI genetic counsellor, but the reality, it's a bit like when you try and I was trying to get some money back from British Airways, and I wanted to speak to a real person that would authorise this refund. However, I just got an AI interface that sent me a completely irrelevant email back. But that's just the world we live in. We have to deal with these AI. In the end, you've got to try and work out how to finally get to a real human being. But that's, why not? If it happens with British Airways, why not with genetic counselling as well?
So AI is taking over our lives, so it's taking over the world's genetics. Let's move it to genetic counselling. So this is one of the issues we've been talking about today and yesterday as well. What kind of uses do we think? I think we're talking about AI quite negatively, but are there any other uses apart from genetic counselling that we can use in this field?
Well, funnily enough, come and have a seat on the table to chat. How do you feel about talking to computers? We're not computers, by the way, but
we're real humans.
But that's what we're talking about. What was I going to? I've forgotten what I was going to say. Yeah, AI. Yeah.
Oh, AI. Yes. Should we be using it? Should we be using it in your field of research? Do you use AI in your work at the moment? Come and grab a seat. Tell us what you do at the moment. First of all, start us off with an easy one. What's your name?
So just call me Greg, because no one can pronounce my actual name.
Okay, good.
Basically, we work in translational research for a cancer diagnostics lab. So basically, we were trying to implement NGS, mainly targeted NGS panels in cancer diagnostics. So AI would be helpful, but I think for our scope it would be an overkill, or it's, machine learning is so nice and everyone talks about it, but what we have is not enough for machine learning. It's just going to create bias and rather create a good algorithm.
Oh, so you think that if you use AI in your research, it's going to create bias? How so?
So the thing is, there are so many things. AI is this one big sack. Everyone throws their fancy software and calls it AI, even though it's not really an AI. It's just, I've got a very limited knowledge. I just speak with people who work with it and try to understand what they're trying to explain to me. That you just need huge data sets. So if you want to have a good AI system, you don't have it for one company, but you take 15, 20 companies, pull their data together, and then try to create a learning algorithm, because then maybe you have enough data to teach it, and maybe it's uniform enough to actually be useful. So AI is amazing, but it comes with so many prerequisites. It's hard to actually use it.
So you think maybe it's actually a bit of a waste in this?
I had a friend that, I'm not a scientist, I'm an artist, but I've got a friend who's a kind of scientist artist who's using the TensorFlow system, which is like the Google kind of generic AI sort of engine that you can use to sort of I don't know, like it's a kind of first step on the AI road. But he was saying that he was actually AI in the end is just statistics. It's just crunching numbers, and computers can't really do insight. Even with the machine learning, they'll never do the insight that humans can do. But anyway, in the art world, you say that art is 1% inspiration, 99% perspiration. So surely the computer can do the 99% perspiration, and you can just stick with the inspiration. So I still think it's got a big role to play in any really creative field, just to actually give humans more time for the creative side.
Okay, so it might be used as a useful tool in science. Greg, you might say that maybe it's more overblown, that people think it's more useful than it actually is.
No, it's more. The thing is, it will be an amazing tool, but right now it's still very much in development. And if you overhype it, you might basically, people will get discouraged because they think, oh, it's going to solve all my problems, and then they learn that no, actually, before they start using it, there are so many conditions to meet. And when someone comes 5-10 years later, hey, we've got this better model, they remember, actually we tried, we didn't like it at all, so no thank you. That just means that just be more careful, more considerate, don't oversell it.
And is that something, we've got a
No, I
over
mean,
here.
I'm just sort of agreeing with you, because in this case, you know, there's a lot of like electronic artists that use data to create all sorts of wonderful things, but the problem is just defining that data. So my friend's problem was always like, how do I feed this data in a way that the AI can produce something out of it? How do I actually define what I want? And that's I don't know if that's a problem in the genomics side, but it's certainly his problem, that you're still left with this, like, he was wrestling with his data sets for like years, literally trying to get it right.
Okay, so you've got maybe some issues with, and maybe some problems with hype. We're talking about maybe trends you think are overhyped in your field. Any final thoughts before you leave, Greg?
I think it's going to be amazing down the road. It's just going to be a lot of time together, and it's it's just this catchphrase right now. Like, you know, a year ago, everyone's saying blockchain this, blockchain that. This year, AI this, AI that. And people just become skeptical when they hear this. So it's been lovely talking to you.
Thank you very much, Greg. Enjoy the rest of the festival. I'm quite interested actually about this kind of like these ideas of hype that's going on. Have there been any other things that people think have been overhyped, maybe at this festival, maybe just in your field in general? What's overhyped in the field of genomics?
Well, I am here because I educate GPs on genomic medicine. I've got the genomics degree, so yeah, I'm sort of here seeing what's going on, what's happening, so that I can bring the message and take into the primary care what will be useful, and trying to encourage that.
Yeah. Oh, very nice. Well, I think we've got a few people. Oh, we've got a new person on the table. Can you? My name's Evie. Can I get your name? Evie with a V.
Evie. Hi, Evie. I'm David.
David. And
Dave, you can call me Dave.
Dave or David, doesn't mind. Have you seen any? I was sort of interested about what might be overhyped, because I think especially a lot of these festivals, you have some really interesting research, but are there things that are a bit overblown as well? What's being overhyped at the moment?
Well, I work in the field of aging, and some people in the field of aging tend to overhype the possibilities. Like, there's people that say that there's someone alive now that will live to 1,000 years old, and I think that's nonsense, to be honest. Not mentioning any names, but yeah.
Would you, if it was possible, if this is a field of research that seemed viable, would you want to? Is it something that we want to start trying to change, like the actual possibility of aging?
Well, just about the overhyped ones, I think we still have to see what comes out of the polygenic risk scores and using them in the clinical care, because at the moment, you know, as a family doctor, it's like exercise, getting enough sleep, healthy diet, keep yourself slim and have, you know, fun stuff going on in the life, and it sort of often comes to that actually, and that reduces the risks. Yeah. So
okay.
we kind of maybe not quite yet usable in the primary care.
over here.
I mean, it's interesting going back to the genetic counselling thing, because we were talking to a guy yesterday. He was talking about like genetic heart problems. What was it? Brachydactyly? No, I can't remember. Anyway, some kind of heart problem, and like when you know that you've got this heart problem, then you have to think about exercising, having a healthy diet. What's that?
Familial hypocholesterolemia.
I can't remember what it was, but anyway, but the thing is, the point is, it seemed to be that would be the advice to anybody anyway of how to live a healthy lifestyle. It doesn't change, you just know that you're more at risk. So it becomes a bit more urgent, but surely it should be quite urgent anyway.
Okay, so maybe we kind of know what the things that we should know about our health anyway. We don't need to sort of pump money into the science of aging because we actually know the answers already. Is there anything, what are the big things that people want to focus on solving? Where I know that cancer is like a really big research field at the moment. What else are people looking into and they think might be able to solve?
I think the pharmacogenomics has got a lot of interest and potential. Yeah, pharmacogenomics, so sort of prescribing medication based on the genetic profile of the people.
Very nice. We've got a thought over here as well. Anyone else wants to join the big table of chat, Talkaoke? Come and grab a seat.
I just want to ask you one thing before you go, which is, as a GP, one of the things people were saying yesterday is like, can physicians, like family physicians, get their head around genomics, because it becomes so specific and so related to genes that you have to kind of know all these different proteins, these different metabolic things, and all these very kind of niche things. And if you're having to sort of go through like all these different genotypes to work out what you're going to prescribe, is that a bit of a headache? I mean, it's an amazing opening for doctors, but does it actually completely change the paradigm in what knowledge you need to know?
Yes, well, that's one of the things I'm doing in bringing into the GP world, and I'm also sort of doing work with the local consortium, GP consortium, and indeed we sort of doing gradual training and introducing it bit by bit and in a way that is sort of relevant to our work. And yeah, GPs are very clever at getting things functioning really well, that they get the teaching and then they incorporate it in their system, so I don't think that should be any problem, but more investment is needed into bringing it primary care, because at the moment we get the training, but there is no sort of funding for any posts that would be particularly sort of like as a doctor. I've done a master's in genomics, but there is no post where I could sort of use it, so I just do it on my free time really to train people and bring it. Yeah, it's my hobby.
I mean, I think that's a good point, because it's not really a sort of specialism like you have, you know, like a psychiatrist or obstetrician. You don't have like a genetic. Yeah, exactly. Yeah. I mean, how? Because I mean, we've been doing this festival for a few years, and the first time there were no clinicians there, and gradually we're seeing much more buy-in from people that actually treat patients, real doctors. What's going to lead to that kind of tipping point where more doctors get excited about genomics?
I think the secondary care doctors and researchers have to actually remember that we as primary care physicians see most of the patients in the country. We are the ones who actually run the healthcare, and without us, you know, it would all collapse. So we are the key, and so kind of like, hey, they are there, they can do something, and we can actually use all the skills that we have. I think GPs are kind of forgotten that it is us, and oh yeah, we see all the patients with rare diseases and whatever, you know, genetic problems. They are there. We have day in, day out these patients. but somehow it's forgotten that we see them.
So genomics research is nothing without primary care physicians. I think that's quite an important thought.
Yeah, I think I mean, in a way, it's the secondary care physicians that actually get all the kudos because they've come up with these amazing treatments. But as you say, you're the ones actually doing the work. And do you feel a little bit underappreciated as a GP that people don't, in the health establishment, don't maybe appreciate enough that role?
Yes. Yeah, we do genetic counseling too, although we don't have so much training for it. So yeah, that kind of thing should be done for the primary care physicians too, because it's not the same as ordinary counseling. It is a very specialist form of counseling, but there's certainly no training for family doctors. And I think that is again one unmet need, that to sort of organize GP genomic counseling events. But now,
Thank you very much.
Kiitos.
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 Where are you based?
Yeah, had a wonderful experience of the London Tube this morning. My journey to work is much better than a minute.
Do you want me to move a chair around? We are Talkaoke, yeah. Have you been to Talkaoke before?
Not in this.
Yeah.
Oh, so you've met us in different areas?
No, I haven't. No.
Oh, okay.
What is the subject again?
It's a pop-up talk show where we've been talking about everything and anything. I think so far we've been talking about genetic counselling. We've been talking about what are the hype bubbles maybe in the field of genomics. We've also been talking about whether we'd want normal counselling with AI. I should say I'm Evie.
I'm Greg from Anthony and Nolan.
Do you say Greg?
Yes.
Yes,
Yeah.
Greg.
Mikey?
What brings you to the field of genomics? Have you got any thoughts on any of the things we've just talked about?
Well, our charity is the principal stem cell transplant charity in the UK. So we're interested in thinking about the new cell and gene therapies and what that could mean for patients with blood disorders or blood cancers. So I think I had it on the agenda. We're talking about how to include patients in the R&D development of technologies. So thinking about what that looks like in terms of that inclusive culture and how patients, and even though it's a really technical issue, what are the elements to which having that insight from patients makes for better technologies and better treatments ultimately.
Okay, so thinking about actually involving patients in the R&D process. I mean, we've got a few people sitting around here, maybe some of them are doing some work, but if you've got any thoughts about how you're going to involve a patient in R&D, come and grab a seat at the table of chat. I kind of want to know how do you get involved as a patient with R&D in that early stage? Like, is it a really hard thing to do for scientists to engage with patients?
Well, it's one of the things we're currently looking at Anthony Nolan is in terms of not just with our policy influencing, but with research as well. At what stage do you want to involve patients in that process? Is it a question of thinking about the ethics and the use of human tissue? You know, what are their thoughts? How can you get their consent on a lot of these processes as well? Or is it in terms of depending what type of study it is, whether it's lab-based or it's ethnographic, thinking about what is the parameters of that study, what does the design look like? So it can come through in different ways, but it's definitely a topic of conversation.
And have you spoken to any of the patients who've been involved in these kind of processes? How did they find it?
I think they find it really rewarding. It's a way of feeling like they're part of the process and that they're actually giving something valuable. And you find that in terms of the end product, whether it's a paper or a technology, it normally is able to be understood by commissioners and by those appraising the technologies that much easier because they understand what the patient benefit is. Because they can hear, from patients themselves their experience and their thoughts of it. So it just creates for a more comprehensive evidence base. So.
Okay, nice. So thinking that actually a lot of patients enjoy being involved in the research stage, or if not enjoy it, feel empowered by it. Would that be right to say? Okay, so we've got, maybe you feel empowered if you're involved. Would anyone here want to get their genome sequenced? I know that's something that is like quite big hyped idea at the moment?
Well, we had a whole bunch of people around the table yesterday, and that wasn't the question actually. It was, would you have your child sequenced?
Oh, okay.
And everyone said yes for their child, but then when it came to them, not so much. So I think that's kind of interesting. And certainly, I think the main issue is about how that data is going to be handled and who owns the data. And, I think it's just unclear. I think there needs to be a protocol, a global protocol about how that data actually gets, also, first of all, how it's ordered and how it's actually kept, but also how it's used and what the anonymity is, or because on the one side you want it to be anonymous, and the other side there's other people that almost think that you could actually make money from that, but obviously you can't if it's anonymous. I don't know.
Okay, so we've got some issues about, would you want to know, should you make money from it, is it okay to make money from it, and also maybe you don't want to know about yourself but you would want to know for your children. Quite a lot.
I mean, does it really belong to you anyway? You got it from your parents, and they got it from their parents. Does your genome really belong to you, or is it beyond the ownership? I don't know.
Okay, so who owns our genome sequence? Greg, have you got any thoughts?
I suppose it's not just. I saw an article the other day looking at DNA sequencing, and they've got these popular public registries, and it's not just the case that you are having your genome sequenced in isolation to have more insight about yourself. You're potentially, if it's on a public database, you're giving insights maybe without consent to new people, maybe unrelated people who you haven't met yet. So it's all these sort of ethical issues and dilemmas, which maybe people at the first instance, they think, I can find out what my life expectancy is, or do I have any extra comorbidities I'm not aware of. But then you could potentially be creating new connections, communications with other people, and that comes with consequences.
Okay, so maybe the benefits to everyone else outweighs what is actually maybe quite a crucial piece of information, but maybe not that many people understand what it's about. So maybe we should feel open about sharing it. Are there? Would you feel open about sharing your genome sequence?
I mean, having this conversation, it's a weird thing. I feel, yeah, fine. It's weird. Yesterday, people, it kind of depends what the conversation is. Do you know what I mean? When you talk about it as a kind of common good, and it sounds really, from that side, yes, I think, you could learn so much more if everyone just gave their DNA and kind of explained who they were, and you can understand because we're only really at the beginning of really understanding the genome. So we need in a way everybody's to contribute. So on that side, yes, but on the other side, if it's exploited, if it goes into the wrong hands, people judge you on it. They judge the flaws rather than in a way the beauty of the whole thing. Then it's bad, obviously. So it kind of depends what mood you're in, but it's such a kind of final. It's like getting a tattoo. Once that information's out there, you can't really erase it. Do you know what I mean? Well, you can hit delete, but it's going to be there somewhere.
I guess it's also about what does data security look like as well, or in the future, how will those data sets be shared with other organisations? So maybe not so much for the UK, but around the world. Whether it's health payer services, life insurance, job prospects. You could find, or your children, given the genomic data carries down, you could find later on that they get denied access to a service or an opportunity because that information is somehow become freely available.
So maybe, it can be misused, parents and children as well, because I guess you're so interlinked with your parents as well. We've been talking about whether we're going to share data with people, how it can be misused. Thought maybe these people at the coffee bar might have some opinions on it.
Can I just say, the thing about health insurance and the health insurers getting this genomic, to me, everyone's kind of saying, that's a problem with the data, but it's not. It's a problem with how health insurance works, because that's fundamentally wrong to make it, I think anyway, make it more expensive just on the basis of someone's genome or any factors really. So, you know, it's like we're critical about the data and the data handling, but it's actually about the business of health insurance we should be more critical of.
So the business of health insurance. These ladies are walking past the girls down here. If you've got any opinions, going to a talk, that's all right. Come back later. So yeah, we've got the business of health insurance is a problem, not the fact that we've got loads of data out there. Have you seen? But there are kind of a mix of businesses here today, and also NHS-funded charities. Do you think they sit well together? Do you think, like in the UK, it works well together?
We have the National Data Guardian, and I think that as a vehicle has worked really well in trying to set down the principles. You know, what does that look like in terms of consent? You know, having that informed consent as well. Those sort of principles and ethics. That's a job of work they've been starting to set out and gain involvement from across the sector. And I think without that, we'd probably be in a worse place, given the explosion of health data that's about to come on the market and to be used by the NHS. So I think the UK is in quite a good position to be ahead of the game on that.
Okay, so in the UK we've got good practices when it comes to genomics and business. Got any thoughts of it? We've also got a new person on the table.
My name's Rick.
Rick, we've got Mikey over here.
Hello. Yes, I agree.
You agree?
Yeah, that's it. I can't say much more than that.
I think I was reading, it was an interesting case of a woman in America whose genome was sequenced against her will, but they're still publishing it today. So it means that her descendants are still affected by the information about her that's out there. And the argument was that this was still very early, it was about the 60s and 70s, and so it was a huge step for people. But they're still affected by the fact that someone's data is out there without her consent, and definitely without informed consent, I'd say.
I mean, I think, to me, the thing that it reminds me of more than anything is, what's the name of that, the woman whose breast cancer cells were reproduced, and there's still a line. I mean, these guys will know inside out, but I can't remember her name, but was it Henrietta something? Anyway, but she died of...
I feel like she's like, I do know who the name is. I do know the name.
You know, come and tell us. Come tell us. We're not experts. Come over. But she didn't really give her consent to that, and that's still going on, you know, now. However, on the other side of it, they've learned so much from this line of cells that it's, you know, once again, it's the greater good. And sometimes, you know, like, science advances in a kind of messy, dirty, slightly unethical way, but that's how it goes.
So is it a good advantage for science? I think, lady over here, do you have any thoughts on that you maybe want to share with the table?
2 minutes.
2 minutes, come on. Okay, maybe later, come and correct it. Yeah, so these are controversial issues. Might disagree with them, might be supportive of them.
It's like the 23andMe, you know, they, in a way, ripping people off with their offer, but at the same time they're advancing the science quite well. So, you know, they're doing it in a slightly devious way, but it is moving the science forward. So should science move forward at any cost? Do we want to have more ethics around it, more understanding about it? Do we want to involve the patients at an earlier stage, for example? We've got some people who've just grabbed some coffee. Maybe they want to come and talk to us about what you guys have been chatting about. It can be about the festival. It can be about what you're just doing today. We've got great minds.
For 2 minutes? Go on, just for 2 minutes.
Come on, yes.
Afterwards, okay. They've promised that they come and visit us afterwards, so we will remember. So we've got, we've been talking quite a lot. We've been talking about, I'm quite interested about the genetic counselling earlier. I don't know whether anyone's been involved in that around the table. Maybe they know a bit more about genetic counselling. Fantastic. Or maybe everyone is a bit sick of talking about genomics. Maybe we want to talk about other areas in healthcare that we think aren't getting the same amount of attention.
I mean, there was a debate yesterday about euthanasia, and there was one doctor that was saying that euthanasia should be on the cards more, because we spend a lot of resources keeping people alive that are really at the end of their lives and suffering, and a huge amount of NHS resource goes into the terminal stage cancer patients and very old people, and a lot of those people don't even want to be alive. They want their pain to end. So it is related in a way to genomics, because there is a question about costs and who's going to pay for it. But the big subject is, how do we actually come up with a fair and standardised protocol of how to pay for health services, if it's not going to be this health insurance model, if it's going to be like this free at the point of access healthcare.
I don't know, do people agree with that? I mean, there are quite a lot of statements there.
I think in terms of thinking about what treatments are available, it needs to be patient-led. In essentially, for the most part, the majority want to have improved outcomes and an improved quality of life, whether it's beyond the transplant or after cancer treatment. And I think for one of the biggest issues right now is, how do we get accelerated access to these new technologies, whether it's CAR T therapy or potentially down the line new gene therapies. It's not just a question of having them be discovered and developed and go through the research pipeline. It's how can we get them to be actually put into clinical use as quickly as possible. So whether that's looking at trial design, basket design and other aspects, how can we enable that to have patients who maybe are terminally ill or near to that status having access to as many opportunities as possible, and that helps us get more research data as well. So I think one of the other issues as well when it comes to clinical trials is people's willingness to actually publish failed results. So that's an issue to which, researchers are understandably keen to publish papers where things are going well and they're getting new insights. But when it comes to failed tests, sometimes they get put into a dusty drawer and they don't get put out there.
And what's the effect of not publishing? Oh, we've got our thoughts over here.
I think, I'm an artist really. And in the art world, we always say that failure is really, really important. You actually learn a lot more from failure than you do from success. But I've always kind of been toying with the idea of having a failures page on our website where all the the worst events and the terrible things happen. Not terrible things. Nobody died, but the gigs went wrong. I'm always kind of tempted to, but at the same time, something stops me from doing that. Probably commercial interest, I'm not sure. But I do agree that you actually learn a lot more from failure, and failure is much more insightful and instructive than success.
So how are we going to... Do we think we don't have at the moment a society that encourages publishing failed research, or even just failed work practices or things like that? Do we have a culture which you think encourages that, or do you think we need to sort of change our perspective?
Well, I think when you look at research academia, it's very metric focused. And that can help to determine budgets within departments as well, and the potential opportunities to access funding for future research projects. So I think there is a culture to ensure that those stats are as high as possible against your competitors in other institutions. So I think we need to find that more. They say academia is collaborative and inclusive, so I think it needs to be actually put into practice as well.
Okay, brilliant. So we've been talking a bit about academia and whether the world the world that we're in actually encourages people to publish failed results, or whether it's very metric driven, as Greg was saying. My name's Evie. Going to just do a round of names.
Hello, my name is Chow. I'm a research technician for Institute of Neurology at UCL.
Fantastic.
I'm Abby. I'm the same. I'm a research assistant at UCL as well.
Brilliant.
Mikey, nowhere.
Mike, no, and we've got Greg over here as well. And who was it that you worked for, Greg?
Anthony Nolan, Stem Cell Transplant Charity.
Anthony Nolan, Stem Cell. Brilliant. And we've got maybe some people in the careers corner as well who are going to come and join us after they've checked out some careers. So guys, we've been talking about failed results and whether you think that is something that's encouraged in academia. Have you guys got any thoughts on that? Experienced that yourselves?
I think failed results, it could discourage some people, but in terms of research, it can be really helpful when it comes to other scientists wanting to, maybe if they're doing the same thing or they think of doing the same thing, it can be like, oh, well, maybe that can redirect us to maybe, coming up with new experiments or maybe just redirecting their research. So.
I think like 99% of what we do is get failed results, but that's to like prove, like basically it's to look for like the true result in like this needle in a haystack kind of situation. So yeah, well yeah, we'll eventually get there by finding failed results. So
one day.
Yeah, exactly.
And what kind of, we've been talking a bit about genetic counselling, we're talking about research, we've been talking about getting the patients involved in research at an earlier stage. Oh, yeah.
I think one of the reasons, going back to this question about failures, is one of the reasons why more patients are not involved is because a lot of these genomic therapies do go wrong quite a lot, and so there's a reluctance from health services to get people involved unless they're really desperate and that's their only choice. So that is a bit of a chicken and egg situation, and our patients, even if they are willing to take the risk, the health service isn't necessarily willing to risk those patients on kind of avant-garde treatments.
Is this something that you guys see in your field? The gentleman who's just sat down as well. Feel free to come and join us, even if it's just 2 minutes. We've been talking about all the issues that have come up at the Festival of Genomics. Is involving patients, is that something that you guys see in your work?
Yeah, so we are a remote study, but we have quite a lot of participants, so every so often we run sort of patient engagement events. Part of what we do is sequencing people for like rare Parkinson's related genetic results. So yeah, we do involve patients, but only every so often we actually get to meet with them. So.
Basically what she said. But I have heard from her that a lot of patients really want to be more involved in the process. They want to know what's going on. They actually have their own comments on how the pipeline, for example, they'll be like, oh, but maybe you could do it this other way. So I think when it comes to patients, they want to take control of their own health and they want to know what's going on all the time. And I think just being more patient-centered when it comes to clinical trials, when it comes to doing research, I think just making them more involved would probably be more engaging, and they'd probably want to be more involved.
We've just been talking about whether we involve patients in genetic research. Come and grab a seat if you've got any thoughts. We've been talking about all the themes that are going on. Just come and have a seat. Come and have a listen. Mikey, you had a thought.
No, I was just wondering, if you were saying that they don't get involved very often, could they be more involved, and could you just kind of have patients hanging around in the lab, just kind of like, to me, we did a thing at the Crick. And they're having this same, they're really big on public engagement, and they're having this same thing as like, how can we involve patients and really just try and have as many open days and things where they can involve in a way the end users of some of that technology. But my perspective in public engagement, that's great, but in terms of research, is it useful at all to have these people around?
What do you think? Can I just grab your name very quickly?
Peter.
Peter.
Hi.
So is it useful having, Greg, you spend a lot of your time trying to advocate for people to get involved. Have you got pros and cons about it?
I think one thing would be quite interesting in terms of the engagement that you guys have done with patients directly. What form of communications have you had with them? Because I found that across the sector, there's been a lot of instances where patients have lay summaries given to them, but even then, they've been condensed, and a lot of the scientific technical information has been taken out. But for the average patient, it's still probably too high a level for them to actually comprehend exactly what is the purpose and the outcome of the study. And even for some research participants, it's still, I think it's still quite rare that after a study they get invited back to hear the results in a way that they understand. I think too often they might just get a letter that tries to, as easily as you can, spell out what their results are and what that means for them. But yeah, I think too often patients that do get involved, they are left wondering, well, what was the point of it, and where's that information, and potentially where's their contribution gone. So I think that's maybe an area that needs to be thought of, expanded upon a bit more as well.
Peter, you had some thoughts on it? Just some nodding.
No, I just, that's interesting to hear and is a good thing to bear in mind for when we're deciding what communication to have with patients. So yeah, that's very helpful. Thank you. Mentioning that to the office later. Thank you very much.
And do you get a chance to actually do any of that communication as people who are...
I was at a patient engagement event like yesterday, actually, weirdly enough. But yeah, I do see what you mean about sort of like having to simplify things and explain things to people. I think it really is dependent though on the disease that you're talking about. So a lot of people with Parkinson's are very, very involved in academia. They're like very keen. They know a lot of the kind of scientific terminology and stuff like that. So I think it's contextual, definitely. For us, another challenge is that we run a longitudinal study, so we have like ethical approval for 25 years, so it's hard for us to show them what their input is actually generating, because the whole point is that it's going to be like a sort of endpoint in many, many years to come in disease progression. But what we do try to do is just keep people engaged, whether that's through like social media or sort of like update events. So we're trying to establish a consortium of Parkinson's patients at the minute who can feed back on our study design and kind of say, well, this is working for us, or this is awkward. And it's especially important when you're working around people taking their medications and if they have to be like time constrained to stuff like that. So it is hard to involve people on a meaningful level, but I think it's just as long as it's consistent, like that's enough. So
do you get any insights from the patient and how they, things like the medication or their symptoms that maybe you don't get just from the theoretical side of understanding the illness?
Yeah, definitely. So in Parkinson's, it's really important that people take their medication on time. There's been this whole big movement recently. And with us, we have to do a sort of keyboard tapping test as one of our measures of like premotor symptoms. And in order to do that correctly, we have to figure out when is best for them to take it during their to do with their medication. So obviously, once you've first taken it, you're feeling a bit better or whatever. Or if you're almost about to take your next dose, you might be a little bit shakier. Also, there's things like having good days and bad days. So all of this feedback we're getting from patients that we couldn't get for ourselves because we haven't lived with the disease. So yeah, that's it.
Do you have any thoughts? I thought that was a hand up, don't worry. Okay, so you think like generally it's been quite positive, and even if they're like long-term studies, being involved at least allows people to feel empowered or to have more information about their treatment. We've got any thoughts over here?
No, I mean, I think that this issue as well about explaining very complex science, I think it is actually quite useful in terms of your own understanding of the science if you can explain to somebody that hasn't got that background but has got symptoms or has got a risk. It's a challenge, but it's a really good challenge, I think, as well for you as a way of explaining it to anybody, to even colleagues in the field, what you're actually doing.
I mean, do you think it's a good investment? Do you think it's easy to talk to like a non-biologist about this kind of science, or is it quite challenging? And like, what are the ways that you get around it if you are trying to communicate those ideas with people?
Yeah, I definitely agree that I've heard it saying that if you can't explain a thing to a layperson, you probably don't understand it as well as you should. But it is challenging because, of course, you get very used to being around people who do know those things and talk about them every day, and you kind of forget what the average person maybe doesn't know. I unfortunately don't have any easy ways to get around that other than just show your explanation to a layperson and see what they ask you. And there might be words in there that you think, oh, of course everyone knows what this means, but often it's not everyone, it's just everyone that you go to work with day to day. And yeah, there's no real way around that, I don't think. I think you just have to show it to an average person and see, do they understand it, and revise it if they don't.
So it might be it's probably a sign. It's a good practice to try and explain these things. We were talking earlier about also genetic counselling, which I guess is it slightly different? Is it more based on trying to explain the facts, or is it trying to like help you? How have you guys seen it being used at the moment, and do you see it being used at the moment?
Yeah, so we do genetic counselling as part of our testing people for these particular results. Thank you. Should I just take the call? Yeah, there we go. As we're testing people. So, we do see it being used. It's kind of different. It depends on what people are asking. You have to definitely set out with standardised information that you're sort of willing to say to them, because you can't tell one person one thing and another person another thing, especially in terms of statistics. But the main things that people are concerned about is how their families are going to be affected by these things, how they're going to be affected by these things. So it can be sort of an emotive thing, and you have to be quite sensitive and just listening within this sort of dialogue rather than spieling at them like, oh, this is the facts of this. So yeah.
No, I don't.
Anthony Nolan operates one of the largest stem cell donor registries in the country, with over 750,000 potential lifesavers on the registry. And I guess there's a form of counselling that comes with that in terms of communicating with the prospective donor, and managing their expectations about whether they might be a match or not, and what that might look like. So through the validation process, they first of all are told they might be a potential lifesaver, and then there has to be additional genetic testing. So yeah, on occasion that can be, you have to let them down, that they, an alternative has been found, and also working with the patients as well, that don't let them become aware at the earliest stage until they actually have a viable match. So that process involves a lot of tacit connections as well.
It's a lot of expectation management. I think we've got quite a few new faces on the table. Peter, before you go, have you got a final thought?
This is too much pressure. I think that was, just to go back to an earlier talk, that was a really interesting point about patients or participants in the study wanting to know the overall results of the study instead of just their own results, because I think that is something that's maybe kind of forgotten about and will be worth bringing up. So yeah, thank you very much for that. I'll keep that in mind. Thank you.
Brilliant, and thank you very much for joining Talkaoke. I'm going to do a round of names.
Greg from Anthony Nolan.
My name is Chow, working research assistant UCL.
Abby from UCL.
Abby.
David. Mikey,
and my name's Evie. So yeah, we've been talking about quite a few things. Are there, what other kind of topics have been coming up? Like, has anything controversial been coming up over the last few days? Anything that you think has not been spoken about enough that you feel actually maybe should be? David.
I was just speaking to a guy who's running he's setting up a cooperative in Switzerland for people to share their genomic information, where they get control of it, and it's not either owned by, say, like in 23andMe, or owned by the government or the NHS, but they have a cooperative where they have ownership and leadership of their data. The problem is, though, is getting the funding for it, because he hasn't got, it's not a non-profit organisation, but I thought that was a really cool idea. And he wants to do it as a global cooperative, so everyone can share their data, but in the way that they have control and they have some say in what's done with it.
Okay, so maybe we said we shouldn't be thinking about private companies like 23andMe, we should be thinking about genomic co-op. Gotta go. Thank you very much, Greg. Have you got any final thoughts before you leave?
I think patients just need to be, there's ways and means of including patients at every point of the research process, whether it's even at looking at trial design, to evaluation and commissioning as well. So I think, maybe there are some sort of disease areas where specialists haven't quite considered that patients could be a useful component, and it actually strengthens the research process. So I think that's a sort of ongoing conversation for people to have and think outside of the box.
Brilliant, thank you very much. Enjoy the rest of the festival.
This guy, Ernst Harford, is talking later about somewhere at 3:50 about this plan, so it might be of interest.
Brilliant. So we've got genomic co-ops. We've got, I was kind of if it's a co-op, it works as in like everyone just buys in a share. It's like a normal co-op, and then we'll go to Mikey.
was that he was. I don't know if you were. I don't know. Catch some of your conversation. Were you talking about like counselling and that sort of thing? Yeah. So what he was saying was that instead of a genetic counsellor is kind of trained to deal with like specific diseases and that kind of thing, but he's got. I think there's be a new job which is like a scientific counsellor that helps people understand all their data and their genomes. Not necessarily because they've got a disease, but just to understand all their data, help them work out what the best things to do with it are, because it's very difficult to do with it. And he's recruited to begin with scientists to do it so they can kind of lead the way. So I don't know if anyone thinks that should be, if you think that's a good new job to have, scientific counsellor. Everyone should have like people have personal coaches for like exercise. They should have, each one has their own scientist that helps them deal with their data.
Passing over here.
I mean, I think in reality it would have to be an artificial intelligence, because scientists, their wages are too high. They get paid too much. So, no, I mean, for what I mean is, I don't mean you earn too much. I just mean it costs too much to have everyone have a scientific counsellor. But I think you could have a scientific AI counsellor that would be cheap as chips.
Well, I don't think that's really. I think that's a long way off still. But yeah, you say it's expensive, but people pay money for things, So people do pay money for things if it's of value to them. So they will pay for it. If you have to only see them, say you only see them once a month or something, pay them 50 quid once a month. People would do that, I think, if it got value out of it.
Got some maybe some disagreement on the corner.
I just think that like obviously the human genome is so wide and varied. Like where would you begin analysing someone's individual genome? You know what I mean? It would have to be AI, and what would be the outcomes? Like what would be the end point of all of this?
No, it's not like the scientific counsellor reads through your genome base by base. It's more that helps you interpret the data, because someone with some scientific training will be able to say what and also be able to pick out the unknown. So well, actually, because people can easily kind of get carried away and Google stuff and say, oh my God, I've got this disease, and like the scientific counsellor says, no, don't worry about that. We can't really tell that. It's just a little bit of a reality check, a little bit way to interpret stuff, help them think about potential studies they could do. Maybe you could say, go back to them, say, oh, maybe you should check your blood pressure, or something like that.
Pass it on.
I think it was really interesting what you said about AI, but I think the main barrier between AI and actually humans is the ability to read emotions, the ability to be sympathetic or empathetic. For example, if someone gets their genomic results saying they're more likely to have this, they have the gene that makes them more likely to have cancer or dementia, then when AI responds to that, it's just like, oh, sorry, change your lifestyle. But when it comes to human interactions, a doctor or a scientific counsellor, genetic counsellor, they can actually have more tailored responses, be like, just be more emotional and be wary of the fact that their life has been changed now, so.
Yeah, I mean, it's also an interesting concept, because wasn't it coming out recently that the NHS are going to offer to do like whole genome sequencing on people, which is like insane. So I mean, like getting the data in terms of that would be like sort of possible, but I mean, is that actually going to happen?
Well, I mean, we were talking yesterday around the table about, if you had a newborn child, would you get their genome sequence that was available? And they're talking about doing that in the NHS. So then suddenly the problem was you suddenly got loads of data and you don't know what to do with it, and so you need someone to help you deal with that.
I mean, to me, I'm a little bit. I sort of think the idea that you own your own genome, it sort of seems common sense in a kind of capitalist world, but at the same time, it's like saying I own nature, like I own the atmosphere. Maybe the equivalent idea to solving the problem of climate change is saying we all own the atmosphere, we're all in this cooperative together. But it's a thing. It's just a thing that's out there. It's evolved over millions and billions of years. Do you really own it? I mean, it's specific, unique to you, but is it really something that you own, or do you just own the mutations that are unique to you? Or do you share that in a cooperative with other people with the same mutations? I don't know. I just think it seems to be here a kind of common acceptance that you own your own genome, but I don't necessarily think that's true.
do we agree? Do you own your own genome? Do your children have to own your own genome? You know, do you have some responsibility to unborn children?
It's not so much that you own the genome, it's like who you want to know about your genome, you know. So do you want that to be in the hands of everyone? Do you want it to be publicly labelled? The other thing is, you know, like we give a lot of data. I was talking about how you give a lot of data anyway to these companies like Facebook and Google. Every time you do something, you've given away data. You've given away lots of things. So maybe it's not, you know, so maybe it's not such a precious thing, your genome data, but I think it's not so much owning it. It's about owning access to it. Who has access to it? And I think that's a big question. I don't know what the answer to it is.
Yes. Who has access to it?
I mean, like, in an ideal world, as scientists, like, we would have access to it. Like, do you know what I mean? We would have, like, a big registry, and say you're looking at a particular rare variant, you'd be like, oh, there's, like, 800 people with this in the UK. Wow, we can contact all of them to be part of this study. But, like, at the end of the day, I suppose you must own your own data and your own genome, right? Like, it's too complicated to be like, oh, for the greater good, like, oh, we have access to this just because it will help, like...
Well, we've got here and then Mikey.
I mean, scientific purposes, you could say, well, I'm allowed to use it's types of use, isn't it? Like, yeah, okay, it's okay to be used for scientific purposes, but not for checking out my insurance or something like that, you know?
I mean, this is the thing. I think we're confusing the data, the access, and what is really just a natural phenomenon with the business models of insurance companies. And the flaw is obviously in the insurance company. It's not in the nature that is just what it is. And, you know, I think the fact that people exploit the data in wrong ways should be controlled from their ends, not from the end of the availability of the data.
Okay, so it's an idea of control. Maybe, would you want to know your parents' genomes? No, maybe you could blame them for things, you know, they, like a lot of your genomes determined by your parents, you can blame them for all the things that they did that then affected you. So maybe we stop thinking about our children, think about our parents.
Well, then the parents just blame their parents, and it goes on and on and on, doesn't it? I mean, you know, in the end you have to accept, like when I look in the mirror I just see my dad, and that's scary. But there's nothing, you know, it's not about genomic information, is it? But anyway, that's my final thought, I think, for this session.
Yeah, we've got some people leaving, so final thoughts before you go.
I think just like if you're in genetic research, always remember that there's a person on the other end of the tube or whatever. So.
Brilliant, yeah.
I think in terms of, you know, you see online there's like, oh, check out what your genome is. I think maybe just avoid that. Maybe you don't need to know, just live your life.
And final thoughts from David as well.
I think it's just a whole new set of issues that we haven't even thought about yet, and that's why we're having this conversation, so it's good to talk about it.
Brilliant. Mikey, any final thoughts? Have you had your final thought?
Long live the genome.
Brilliant. Well, I think we might have a quick break, a quick Talkaoke host stop. If you're curious and been watching...
Huge round of applause for Evie in the middle.
Thank you very much.
Oh, it's not that big.
And come and join us. If you've been sitting on the sidelines and you think, oh, I really want to join in, but I'm just not sure how, you've probably got a few moments to gather yourself and then come and join us for the next session.